Hi, welcome back to the second class, part two of Federated Learning. Part one was a theoretical definition, features of Federated Learning, but part two is a case study or a practical example, analogy to learn how Federated Machine Learning works. So, Federated Machine Learning, as we defined it earlier in the first class. It's a technique where you've got many devices or organizations. They all collaboratively train a machine learning model without seeing each other's data, so without sharing their own private data. So that's basic federated machine learning. So real world example, for example, we have smartphones which predicting the next word in typing. So companies like Google use this type of machine learning, which is federated machine learning, in the Gboard keyboard, which is Google board keyboard. And the process is like this. Phone trains model on user typing, and then phone sends model updates only to the server, and then server will aggregate these updates from each phone, and then the new board model is sent back to each client or device. But your messages never leave your phone. So federated learning is likely many chefs improving the same recipe without sharing their secret ingredients. I'll go through the steps of federated machine learning. First of all, we initialize, or the server will initialize weight matrix. We call it initial weight. So initial weight, W dot initial weights. This will be initialized randomly by the server. And then the model is sent to all other devices. And each device trains the model using its own private data set. For device K, for example, machine K, you've got the WK equals W dot, the initial weight, minus the learning rate, eta, multiplied by the change of the error in relation to the weight. So change of the error loss in relation to the weight. So these are the parameters: global weights, local update weights, learning rate, and local loss functions. So that's the error in each device. So each device performs several gradient descent steps. Now, step 3, send model updates. So each device will send its update to the server, back to the server. So device send model updates, not the raw data, the updates, not the data. The updates means the weight matrix and biases back to the server. So you've got delta WK equals WK minus initial weight in the server. Now, in the server, all these weight updates from each server, from each client, from each device will be aggregated through this formula. So the average federated weight will be calculated by having the sum of weight in each device multiplied by number of samples on each device over number of samples across all devices. So that's the basic formula on how you find the weight matrix the aggregated weight matrix in the server. So, and then the aggregated later on, the aggregated model becomes the new global model, and it will be sent back to each device. And the process will be repeated. For example, local training, send updates, aggregates in the server, and then server sends the aggregate weights to each model, and then model will do training and sends updates, and so on and so forth. So I'll try to provide an analogy for this federated machine learning technique. For example, chef improving a recipe. For example, if we have many chefs, each one tries to create a best soup recipe, but they cannot share their ingredients because they belong to different restaurants. So participants, we have Chef A at restaurant A, Chef B at restaurant B, and Chef C at restaurant C, and so on and so forth. And we have one central coordinator. So initial weights or initial recipe, global model in the server will be given to each model. And that's, for example, the parameters: salt 5 grams, pepper 3 grams, garlic 2 grams. This is like initial machine learning model. So 5, 3, 2. This W will be sent to each device, and each device tries to modify, tries to cook the soup and modify it and improves the recipe. So example, Chef A produced 6, 4, 2, while Chef B produced 5, 3, 3, and C produced 7, 4, 2. So these results, each device will send it back to the server. And for example, that's the outcome from the updates, the weight updates from A and B and C. There will be no secrets, no revealing anything about the restaurant. They'll be sent to server, and the server will aggregate them, and we will have a new update, and this new update, new matrix, will be sent back to each device to retrain the model again, and so on and so forth. So that is the global recipe. And then this global recipe will be sent back to each device, and each device tries to train it and get a new result sent back to server, and so on and so forth. So this is basically about the analogy of federated machine learning. Chef is a device or client. Recipe is the machine learning model. Ingredients, local data sets. Cooking is the training, and recipe is model weights. Coordinator is the central server. Now, the machine learning can take any machine learning algorithm, such as backpropagation or backpropagation, real-time backpropagation or backpropagation through the time, or meta-heuristic algorithms. They can train the devices and the server. So this is all about this class, the practical part. If you have any information or for further information, you can check that link and get information. Thank you very much, and stay tuned.